Hello. This talk is about Bookworm. It's a code crawler that we built on top of RuboCop. I'm David Crosby. I'm a production engineer at Meta. We make Facebook, WhatsApp, Instagram, Quest, a bunch of stuff. And I primarily work on our Ruby tooling, specifically in particular the tooling that we have around Chef. So you're probably, if you don't already know, Chef is a Ruby DSL for configuration management. So it gets the files and packages that you need on the system onto the system. And Meta's been using Chef for over a decade now. Phil Dibowitz first did a talk back in ChefConf 2013. And it fundamentally hasn't changed. It's basically been the same model since then. And the open source that we put out and continue to put out, still being used by greenfield projects, by other companies and internally. So it's kind of a niche API, but it scales gloriously. Metascale, if you're not familiar, is sort of you're operating at millions of servers. So that's a pretty decent Ruby footprint. We're not really known for that, but it's there. So to manage all of our Chef code, we were using Food Critic, which it was a linter that it predated RuboCop by about a year thereabouts. And it had some decent traction, but got to about 120 rules, but it was Chef specific. And so in 2016 thereabouts, Food Critic was end-of-lifed, and a new plugin for RuboCop called CookStyle came out. The problem is, inside Facebook at the time, we still had a whole bunch of internal Food Critic rules, so we largely just kept RuboCop for style. And we sort of kept Food Critic alive internally. But Food Critic was kind of missing an important feature that's not terribly obvious if you're just thinking about things as style linters. So real quick, who here has ever worked like an industrial job where you got to like drive a forklift or work with heavy machinery? Like not just a keyboard. Okay, that's great, because then you probably haven't seen this one before. So this is the hierarchy of hazard controls. It's fairly simple to reason about. Basically, the stuff that's happening at the bottom, it's kind of the least effective way of keeping your fingers. You want the stuff that's at the top. So like one example of this, there's this thing called the bandsaw, which is an awesome tool. It's just this blade that goes really fast, and it will just rip through wood or whatever like butter. The thing is, though, it is incredibly dangerous. So, like, at the bottom of this, you're wearing Kevlar gloves or, safety glasses. But like that's not going to protect you from a blade like that. So you could have a dead man switch. So if you get pulled in or something, it's going to stop. You could also, if you look at the yellow one for isolating people from the hazard, you could put in safety guards. So that way, maybe you don't be directly interacting with the blade, because if that blade breaks, it flies into the air, scares the pants off of you, and you decide you don't want to work in industry anymore. Like the safest option with a bandsaw, don't use one. So elimination, you physically remove the hazard, get something pre-cut. Now this also can apply to software. So I'm surprised I still have to say this in 2025. Linters are important. Red at the bottom here, that's the get good school. That's using Vim, no linters, no syntax highlighting. Like you can do it, it's awful. It sort of assumes that you're perfect, which we're human, we're obviously not. Now you can go up a level, and you got peer code review. But now you're sort of relying on a Swiss cheese defense. So like, okay, you've got some person who's an expert. Well, what if the expert goes on vacation or something? Well, now you're back to red zone. So you want something that's operating at the very least at the yellow. So that's a linter that's in your continuous integration system. It's happening on every single commit. Food critic will just live in yellowed because that crucial feature that it's missing is autocorrection. RuboCop affords autocorrection. So that actually gets you to one layer up, where you are now taking unsafe code and making it safe. Because if all you're doing is complaining about things, people don't always know how to fix that. You're working with a broad range of expertise in any given environment. And if you're operating with hundreds of engineers, like, yeah, there's going to be engineers who they will do the barest minimum to get code shipped. Yeah, let's, real quick, I want to take a look at a real example that you can see, again, with a large environment. You are trying to assign a constant to foo. That is syntactically valid, but quite obviously wrong. So you're not going to see that explode necessarily until runtime, which is going to be a problem. So we've got a lot of smart folks in the room. We can actually just make a RuboCop rule to deal with this exact problem right now. So let's do that. So this is a real RuboCop cop. We actually open sourced this one. We're open sourcing more of what we've got. And all it's looking at, so we've got our class named Python caps. The onConst method here, what that's doing is it's a handler. So you've got this abstract syntax tree of your source, and the different nodes of the AST. As RuboCop's traversing through that tree, you want, in this case, to say, okay, we see a constant, let's fire on that. So we fire on the constant, and the def node matcher, what this is doing is it's actually creating a new method called const caps true false. And the really fancy string in there is the node pattern API. Now this thing feels like the bandsaw of RuboCop. It's awesome. It's probably overkill for this particular example, but I wanted to show it off. So we've got a constant, and we're looking for if that constant's name is false or true. And if it is, we're going to add an offense. Hooray! We're now at the yellow of that triangle, so this is a good thing. Now, here's how we turn it into a green. We add the extend autocorrector line, and we pass, we have a block where we have the replace method. And we're going to take that particular node's range of source, and we're now going to take the short name, so either capital F false or capital T true, and we're just going to downcase it. There, we've now replaced that with a string that says true or false. So we've taken a constant and we've changed it to a Boolean literal. Apologies. Writing code rewriters, sorry. Okay, I just came back from riding the Shimanami Kaido for several days. I'm still getting back to humanity at this point. Facebook has code mods sort of in its DNA. We put out a code mod tool for PHP back in 2007, 2008. And code mods are basically how you do coding at scale. Now, there was a really good talk about how to do this in Ruby in the 2024 RubyKaigi, so I'm not really going to go over it. But I mean, if you aren't already using RuboCop for large-scale refactors, like, I'd really encourage it. Like, as I was saying, writing code rewriters, it seems overkill at first. And I mean, this seems like a fairly mathy slide. I won't try to bore you with it. But basically, the thing is, when your n is small, it seems like overkill. But you want to be building that muscle for like how to use the node pattern API, because again, that sucker is the bandsaw of RuboCop. That is the good tool. You've got this cool way of finding code patterns, and how do you build that muscle? Because like the node pattern API, it absolutely made me a better Ruby programmer, and I've been doing this since Ruby 1.8.7. But like, it's a muscle. You got to use it a lot. So I'm going to leave you with this cliffhanger for just like a little bit. Take a sip of water. So sometimes to think about, if you want to come up with new things, you kind of have to assess the current state of what you've got and come up with all of the things that really bug you. Just to be totally transparent, I'm going to beat up a bit on RuboCop and Chef. So like, don't take this as like me being nasty here. So RuboCop, it operates on one file at a time. So let's say you wanted to see if that cookbook was referencing something else. Well, you can't really do that unless you're like using global state within RuboCop, which you can do. Don't. It's really gross. There's also one common thing. So I do a lot of training for people to be writing RuboCop cops within Meta, and we see this fairly often where someone writes a working cop, but they actually haven't tuned it to the correct files. And so because in Chef you have this concept of cookbooks, which are just like a collection of files. You've got recipes, you've got attributes, so you've got metadata.rb files, you've got definitions, it's like on and on and on. If you want to tune to just what you want, like you're really using two different languages, and I don't know, I would rather write Ruby than a whole bunch of YAML. Then there's also, again, node pattern AST. You can do, like, as a querying language for a whole bunch of code. Like, it's great. How do you use RuboCop to show you neat stuff about the code that's not, like, really a problem? So RuboCop, you've got the info severity, which, I mean, that sort of scratches the itch because it's letting you know what things it's seeing in an individual file. But let's say you want to know a really cool code pattern across a whole whack of files. Now, for that, you're going to need like a post-processor. You can write a formatter for RuboCop, but like, no, you know, it's just not great. And like, I want to be using the cool thing. And so now I get to beat up on Chef a bit. So Chef, it has issues that, you know, so one problem that you'll often see is you have this concept of resources. So a resource can be like a directory or a file or an RPM if you're using a Red Hat system. And you can have Chef notify you when a particular file has been written. Well, if you are spreading those notifications across a whole bunch of cookbooks, like over time, that you get a real, it's like trying to pull a cord out of a bundle of cords. It's awful work. Then you've got transitive cookbook dependencies. So you can be using a cookbook, you think you're done with it, you go to delete it, and it turns out that that cookbook was used in a dependency chain to pull in some totally unrelated cookbook. That's just bad. And can RuboCop tell you about the absence of a thing? Not so much. We end up with this problem where it's a lot easier to keep adding code over time, and you end up with this cruft, and it's not, like, if the cruft isn't used, is it a problem? There's certainly many situations in the past, not just Meta, but like in many companies, where things that were left behind and thought were no longer to be active suddenly pop into use. So we want to clean up cruft. How do you do that in a way that's not going to blow up at runtime? As I mentioned, we've been using Chef for over a decade, and tens of thousands of recipes and libraries. I've yet to meet anyone who's able to keep all of that in their head. And I think that would actually be a pretty awful existence if you did. There's assumptions you can make on a code base this size. I won't say them outright so I can keep my job. But right around the time that I was doing the cook-style transition, there was this book I read called Kill It With Fire, which is an excellent book. And a lot of it came down to, you need to be able to keep the code base in your head. And so you want to start building tools that allow you to do that. And so that's where we came up with Bookworm, because it was tooling that just didn't exist at the time. As far as I know, there still isn't something that really scratches this itch. And Meta's a company where we can really explore these problem spaces because, again, like if you can't buy your way out of the solution, you just have to build it. This makes our ability to look at a code base where we're talking hundreds of cookbooks. Like if you have 10 cookbooks, sure. If you got hundreds, this is a tool that you want. So there was a variety of problems that we wanted to solve, and I'm not going to go into like each one of these, but we knew that in the course of solving these problems, we were going to come up with new questions of like, well, then how do we delete these things? How does it get to be that we can do this safely? What is the order of operations there? And not just this, but it's like, what if we wanted to change one set of code into another set of code, or at least keep something in sync? Basically, we come out with this situation where there's a pattern that we want to follow. That pattern being that you're going to crawl files. So in this case, we're crawling a particular set of files. We got metadata.rb. That gives you the metadata of the cookbook. So what things it depends on, what its name is, the description, et cetera. Then you got your recipe code. This is the code that actually like drops the resources onto your system. And then you've got the attributes, which is how you configure a given cookbook. So we crawl all of those, and we keep them in little segments called keys. Now, if I had known how long this thing was going to have lasted, we'll give it a different name. We still can. But why they're called keys is because they're keys of a hash, and the knowledge base is just a hash of hashes. And so you've got the crawler. The next part is you're going to take the node pattern AST, and you're going to do pattern matching against this knowledge base where we've taken all the AST we extracted from the code and just run over and over and over. And we're now filling up that knowledge base with all this information separate and extracted from that code. And then that knowledge base can be fed to a report. Now, a report, it can be whatever you want it to be. It can be as simple as a list that tells you what the cookbooks are. It can also be a transpiler that, we left a lot of room there because we didn't know what we needed, and we knew that those needs were going to change pretty wildly over the next few years. So there's a few design philosophies that we've taken, and one of which is people don't want to use a fancy tool if it's hard to use. Doesn't matter how good it is. It needs to be easy to explore, to inspect, to fix. It's easy as a bicycle, I would say. And if people can use grep and shell, they will. So it needs to be better than that. So we put in strategic breakpoints at each part of that process so that way, okay, well, you've now crawled everything and you want to inspect the AST to figure out what's going on. Cool, drops you into an interactive debugger. We've also got the profiler RubyProf built in so that you got something slow, well, that should be a quick step. You shouldn't have to be jamming these things in. And I mean, this is the thing I would love to see in more Ruby stuff, is the ability to introspect into what you're doing, because like this is like one of the superpowers of Ruby. So yeah, the other thing is, again, I've trained lots of people on Node Pattern API, and that's rad for RuboCop. But how do you use it for other things? Because like there's definitely a learning curve there. So with this, if you've got knowledge of how to do pattern matching in RuboCop, congrats. You've already figured out most of what you're going to be doing in Bookworm. Yeah, so I mentioned that there was a rule that kind of extracts all that information. Like, here's a very simple one. And I can actually show a bit of code right here. So in this case, Chef has this concept of roles. Roles are basically, okay, this is an Nginx server. So the run list would have like an Nginx cookbook or whatever. But we got the name, we got the description, we got the run list. Now, what this rule is going to do is we've created a role name method using that, again, that really cool Node Pattern API, where if we see the name method, we're going to take that string literal, we're going to extract it out, and then we're going to give the AST of that particular file to the role name method, and great. So now what we can reason from this is the return value of output is going to be fake underscore role. Now that seems like a sort of trivial thing, but like the value of RuboCop is not that you've got one cop. The value of RuboCop is that you've got lots of cops. So the same thing applies with Bookworm. Each thing should unlock the potential for more things. And so over time, as you keep building out more and more stuff, it gets easier, and that gives you a leg up on, instead of doing, I wrote this hacky shell script which just greps over things, you can keep reusing these things and build on the work of others. So this is a very simple report. And what's great about it is, like, again, just from the rules, you can already see, okay, well, we've got the role name that we just looked at. Role description, you could probably guess what that's doing. Same thing, but just with the description. And we can take that, and we're going to go over all the role files, and we take the role name, role description, and now we have a nice tidy list. And that ends up being something which, again, with grep and shell, not as nice. And the benefits here are, now if there's anything else we want to be doing with the role name, so like say you want to make role name and show all of the, say you wanted to do a role names for anything that's using a particular recipe inside of its set list, or its run list, you can do something like that pretty easily now. And another thing is, because we operate in this environment of hundreds of engineers, some of whom have used Ruby for years, some of whom have used it for days, we need to make sure that one rule doesn't make the entire thing slower. So like when we look back at this, we see like, okay, we got the role name rule and role description rule. Well, we're not firing that on everything. And because both rules are only specified for role files, that means that when you do that report, it's only going to go over the rules, which again, we're talking, when your N is huge, you really only want to be working on the things that you actually care about. So one last example, just to show you can do more interesting things with it than just role names, but it still fits in a slide, is this one where, okay, let's take all of the dependencies that are in a metadata.rb file, and we can just put them all into a set, and we can actually, with this, determine all the leaf cookbooks that are within a given code base. Why do we care about this? Well, this lets you know, like, these are cookbooks that if we realize that it's not actually being used anymore, that cookbook is safe to delete. Which, again, when you're talking really big N, you want to be able to say, yep, this cookbook is safe to delete. You can do more and more complex things. There's one rule we open source called the cookbook dependency shaker. And it's got some really advanced logic. It's almost as big as the size of the engine itself. But that's easy to see because the engine itself, because it's reliant on RuboCop to do a lot of the heavy lifting, you can actually read the entire thing in a lunch break. That's an intentional plug, because I know where that's just coming up. And yeah, the entire thing's under 1,000 lines of code, which like to have a framework that allows you to just sort of rip through a whole bunch of Ruby code and come up with really interesting information. That's pretty nice. Yeah, so the code for Bookworm is open source. We would love for more people to play with it. I think it would actually be really useful for Rails, but we don't. We're mostly using this for Chef right now, so that would be a good thing for if anyone's looking for a fun project to pick up. And we also want to get more language support in there. So like right now it's just Ruby, but like the node pattern API, from what I could tell, like because it's just on it's just using the AST gem, like that could probably be abstracted to any other language too, which would be really useful. There is an unrelated gem called Bookworm in rubygems.org. There's this is where namespacing would be great. And yeah, we keep the engine's source synced with GitHub. So if you're using the main branch, so are we. So feel free to file any pull requests you find. So yeah, a little bit early, so that's good for lunch. If anyone has any questions, I'll try to wear this cool shirt. And yeah. Thank you very much.